welcome to True Projects. In this video, we are going to explain about the project which is machine learning for real-time heart disease prediction. Heart failure is a significant health concern worldwide, characterized by heart's inability to pump blood efficiently. It poses a substantial risk to individuals' well-being and remains a leading cause of mortality. Early detection and intervention are crucial to mitigate its effects. The existing systems for detecting heart diseases involve time-consuming manual interpretation of electrocardiograms, which are ECGs, by trained professionals. However, the accuracy of this process can vary, and it may not be suitable for timely identification of asymptomatic cases. There is a need for a more efficient and accurate automated system to swiftly identify heart conditions, especially those without evident symptoms, to improve patient outcomes and save lives. Machine learning techniques are employed to create a real-time system for predicting heart failure. By analyzing patient data, including demographics and clinical measurements, the system classifies individuals into risk categories, enabling early intervention and improving patient outcomes. The primary objective is to develop a real-time heart failure prediction system. By analyzing a combination of patient data and medical parameters, this system will accurately identify individuals at risk of heart failure before clinical symptoms become evident. This proactive approach enables timely intervention and personalized medical care. A suite of advanced machine learning algorithms are aimed to be employed, including KNN, random forest, decision trees, voting classifier, XGBoost, SHAP, and Optuna. These algorithms will work collaboratively to enhance prediction accuracy and interpretability. Ultimate aim is to save lives by enabling timely medical intervention, thus reducing the severity of heart failure and healthcare costs. It also seeks to contribute valuable insights into medical research and empower healthcare professionals with interpretable models for improved patient care. For implementing the project, we need requirements, and they are hardware requirements. In hardware requirements, operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. To implement this project, we have designed few modules in the flow of work. And the first one is importing the packages. This module involves importing essential Python libraries and packages, and they are NumPy and Pandas for data manipulation, Seaborn and Matplotlib for visualization, and scikit-learn for machine learning models. Exploring the dataset using heart failure data. In this step, the project loads and explores the heart failure dataset to gain insights into its structure, features, and data distributions. This exploration is crucial for understanding the data. Data processing using Pandas data frame. This phase includes data cleaning, pre-processing, and organizing the dataset using Pandas data frame. Tasks such as handling missing values, data type conversions, and other necessary data transformations are performed. Visualizations using Seaborn and Matplotlib. This module focuses on creating data visualizations using Seaborn and Matplotlib. Visualizations help in gaining a better understanding of data through charts, graphs, and statistical plots. Feature selection. In this step, relevant features from the dataset are selected. Feature selection aims to choose the most informative features for the machine learning models, improving model performance and reducing computational complexity. Building the model. In this module, we train the model using different algorithms, and they are KNN, which is K nearest neighbor. It is a supervised machine learning algorithm used for classification and regression. It classifies data points based on their similarity to neighboring data points. It is employed to classify patients into heart failure risk categories based on the similarity of their health data to neighboring individuals. It is used for its simplicity and effectiveness in identifying patterns in healthcare data. Random forest. It is an ensemble learning method that constructs multiple decision trees during training and combining their predictions for improved accuracy and robustness. It is chosen for its ability to handle complex relationships within health data. It is used to create a more accurate heart failure prediction model by combining the predictions of multiple decision trees. Decision tree. It is a tree-like structure that recursively splits data based on most significant attribute, creating a hierarchy of decision rules. It is used for its interpretability. They help in understanding which patient characteristics contribute most to heart failure risk, aiding in medical decision making. Voting classifier. It combines the predictions of multiple machine learning models and selects the most frequently predicted class as the final prediction. It is used to improve prediction accuracy by leveraging the diverse strengths of different algorithms. It is beneficial when multiple models provide complementary insights. XGBoost, Extreme Gradient Boosting. It is known for its speed and performance. It is sequentially builds an ensemble of decision trees. It is selected for its ability to handle complex datasets, and it produces highly accurate predictions. It is used to enhance the project's overall prediction accuracy. SHAP, Shapely Additive Explanations. It is a technique for explaining the output of machine learning models by attributing the contribution of each feature to the prediction. It is used to interpret models' predictions and understand the impact of individual patient characteristics on the risk of heart failure. It provides insights for medical professionals. Optuna. It is a Python library used for automated hyperparameter optimization of machine learning models. It is employed to fine-tune the hyperparameters of the models, optimizing their performance. It automates the tedious process of parameter tuning, saving the time-consuming and improves model accuracy. Coming to training the model. After building the models, they are trained on the pre-processed dataset to learn patterns and relationships between features and outcomes. This step is essential for making predictions. Flask framework with SQLite for sign-up and sign-in. This phase integrates the Flask web framework with SQLite database to implement user sign-up and sign-in functionalities. The project includes designing user interfaces for registration and authentication. User gives input as a feature values. Here, user gives input the required feature values through the web interface, which are collected for prediction. Train models used for prediction. The trained machine learning model selected from the previous steps is employed to predict the outcome based on the user's input feature values. Final outcome is displayed through frontend. This project displays the final prediction outcome on the web frontend. Users can view the result of the heart failure prediction based on their input, providing valuable health status information. Comparison graph. This is the comparison graph of the project. Here on the x-axis we have the accuracy scores and the y-axis we have algorithm means. This is the bar graph of accuracy scores of all the algorithms. Among all the algorithms, voting classifier is performing well, so we use voting classifier for prediction purpose in the web interface. For execution, we need to open the code folder which contains the source code files. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, etc. which represent different pages of the website. This is app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. This is the model file which contains algorithm information, and this will be loaded into the project code during runtime. This is the notebook.ipynb file. This is the Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. Now I will copy this path and open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path. This command is used to change the current directory to the code folder's path. Now we need to click on enter. So the current directory is changed to the code folder's path. Now we need to type python space app.py. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is 127.001, which is this one. This is the local host and this one is the port number, unless configured differently. Now we need to copy this local link and paste it in any browser. So I will copy it and paste it in Google Chrome. So here I will paste the link and then click on enter. So this has redirected to the web page which is displayed in the browser, and this home page is developed using Flask framework. Now we need to click on sign up. Here we need to fill all the registration details if we are registering newly. I have already registered, so I will directly click on sign up. Now I need to fill these credentials, which are username and the password. Now I need to click on login. Here this has redirected to the home page. Now we need to fill all these medical parameters of the patient and then click on predict. For those parameters we will get the prediction whether he has heart failure or not. Now we will fill these details step by step. Here we will enter the age of the person and the anemia, which is 0, which means he has no anemia, and the creatinine, which is 582, and the diabetes as 0, which means he has no diabetes, and the ejection fraction as 20, and the blood pressure as 1, which means he has the blood pressure, and the platelets count is 265,000, which is 2,65,000, and the serum creatinine as 1.9, and the serum sodium as 130, and the gender as 1, which means he's male, and smoking as 0, which means he has no smoking habit, and the time is 4. Now we will click on predict. So it is predicted that he has the heart failure, and the percentage of risk is 99.3 and the risk level is high. Now we will fill other patient details and see what will be predicted. Age is 70, anemia is 1, which means he has anemia, and the creatinine value as 80, and the diabetes as 0, which means he has no diabetes, and the ejection fraction as 30, and the blood pressure as 1, which means he has the blood pressure, and the platelets count is 4,27,000, and the serum creatinine as 1, and the serum sodium as 138, and the gender as 0, which means she's female, and the smoking habit is 0, which means she has no smoking habit, and the time is 12. Now we will click on predict. So it is predicted that he has the heart failure, and the percentage of the risk is 51.3 and the risk level is medium. Now we will fill other parameters of the other patient, and the age is 70. Anemia is 0, which means he has no anemia, and the creatinine is 122. Diabetes as 1, which means he has the diabetes. Ejection fraction is 45, and the blood pressure is 1, which means he has the blood pressure, and the platelets count is 2,84,000, and the serum creatinine as 1.3. Serum sodium is 136, and the gender is 1. The smoking habit is 1, which means he has the smoking habit, and the time is 26. Now we will click on predict. So he has the heart failure, and the risk is 94.26% and the risk level is high. Now we will fill other patient details. Age is 53. Anemia is 0. Creatinine is 63. Diabetes is 1. Ejection fraction is 60. And the blood pressure is 0. Platelets count is 3,68,000. And the serum creatinine as 0.8. Serum sodium is 135. Gender is 1. Smoking is 0 and time is 22. Now we will click on predict. It is predicted that the test result is no, which means he has no heart failure, and the percentage of risk is 9.74 and the risk level is low. In this way, we can give the medical parameters of the patient, and for those parameters, we will get the patient has whether heart failure or not, and we will get the percentage of risk and risk level also. Now we will sign out. We have successfully developed a real-time heart failure prediction system utilizing a diverse range of advanced machine learning algorithms. These algorithms including KNN, random forest, decision trees, voting classifier, XGBoost, SHAP and Optuna collectively contributed to highly accurate predictions and enhanced interpretability. But voting classifier stood the best because it is having the higher accuracy and that was used for prediction purpose. The implementation of this predictive system holds immense potential for transforming the landscape of heart failure detection and management. By identifying at-risk individuals early, we can facilitate timely medical intervention, reduce the severity of heart failure, lower healthcare costs, and ultimately save lives. Looking ahead, further refinements and integration with healthcare systems are essential. Continued research and collaboration with medical professionals will allow us to refine the models, expand their real-world applicability, and contribute valuable insights to find the cardiology. Our goal is to make a lasting impact on healthcare and patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.